This is part 14 of the series Integration, and we're continuing on with our integration practice. And here in this problem, you might be tempted to say, oh, let's just use the quotient rule. Please avoid knee-jerk reactions because we're not differentiating here. This is one of the most common mistakes people make, is they get confused between integration and differentiation. So what we're dealing with is trying to match a pattern here. And we're not going to be able to do it in this form, but I can see that if I were to differentiate this term inside the square term in the denominator, I would have a negative 4x, which is what we have in the numerator. So this is what we need to use, but I can't use it in the denominator. So I'm going to rewrite this so that I can. This is actually going to be the integral of negative 4x times 1 minus 2x squared to the negative 2 dx. We just pulled this into the numerator, changing the sign of the exponent. And remember, our restriction was that we couldn't take the antiderivatives with a negative 1 exponent, but we can do fine with a negative 2. That's not a problem. So now our u becomes 1 minus 2x squared, and our du then is negative 4x dx. So rewriting our integral, we get the integral of u to the negative 2 du. Take the antiderivative, and we have u to the negative 1 over negative 1 plus c, which is negative 1 over the u, back substitute, 1 minus 2x squared plus c. I hope this repetition is starting to help. Let's move on to the next problem. So here we have another trig function. This should look a little familiar. We've done something like this in the past. Let's again go ahead and rewrite it. So we have the integral of cos x squared times sine x dx. So we're going to let this be our u. And then our du is negative sine x dx. And you'll notice that we have a superfluous negative sign here. So we're going to pull the negative sign over. So that's negative du equals sine x dx. So now we have a pattern match. And so that's the integral of u squared times negative du, which we're going to pull that negative sign out as though it's a multiple of negative 1. So we have negative integral of u squared du, which is the negative of u to the third over 3 plus c, which equals negative cos, let's put this over here, cos to the third x over 3 plus c. So in case you missed it, I just back substituted here for my cosine into here. So that's cosine to the third, and the negative stayed outside, and I just carried over the 3. All right, let's move on to the next problem. In this problem, we're taking a definite integral. Now, the process is largely the same, but we're going to have to exercise great caution with these limits of integration, because if we're using u substitution, these limits are going to change. So let's go ahead and start the process and see what we're talking about here. So my first order of business is to use this as my u. So I'll say u equals x squared plus 1. And then my du equals 2x dx. I have an extra 2 in here, so I'm going to pull that out. So du over 2 equals x dx. Let's go ahead and do our u substitution now. So we have the integral of u to the third du over 2, pull out our 1/2, integral of u to the third du. Now we have to consider our limits of integration. The limits of integration in the original were in terms of an integral with respect to x. In this case, we're taking an integral with respect to u. So we have to consider whether or not these values will change regarding an expression of x versus an expression of u. So here we have u equals x squared plus 1. So if these values are going to be substituted in for an x, we need to substitute in here to determine what our new u value is going to be. So 0 squared plus 1 is going to be 1. So when the lower limit is 0 in terms of x, it's going to be 1 in terms of u. Take the 1, substitute it in. 1 squared is 1 plus 1. When x is 1, u is 2. So this limit becomes 2. Now I can go ahead and evaluate my antiderivative, or my definite integral I should say, with correct limits. You could have just gone ahead and anti-differentiated here, but as soon as you put in limits, if you had entered these limits, you are now incorrect, and you would have had a major problem. But if you shortcut and take your antiderivative and then try to evaluate, you could take your antiderivative, back substitute your x term in, and then evaluate at these new values. You could do that. It's kind of a kludge, but you can still do it. But it's a waste of energy, because here you have a much simpler expression. That was the whole purpose for taking the u substitutions. So let's evaluate. 1/2. This is u to the fourth over 4, evaluated from 1 to 2. So this gives us 1/2. This is 2 to the fourth over 4 minus 1 to the fourth over 4. This is 16 divided by 4, so this is 1/2 4 minus 1/4. Which, after we simplify the fractions, we get, we get 15/8. All right, so let's move on to the next problem. For this problem, we're going to have to go ahead and rewrite that denominator to put it in a form we can work with. So area equals the integral from 1 to 5 of x times 2x minus 1 to the negative 1/2 dx. So this becomes our u term. So u is 2x minus 1. Our du is 2 dx. And we divide out the 2, so du over 2 equals dx. Now we've taken care of our dx term, but we still have this x hanging out here. So we're going to have to rewrite this and solve for x to get a u expression. So let's do that over on the right hand side. Let's move this over here, and we can say that u plus 1 equals 2x, u plus 1 over 2 equals x. So now we're going to have to go back and substitute these things in. So area equals the integral of u to the negative 1/2 times u plus 1 over 2 du over 2. So the first thing we're going to do before we handle any of this statement is not yet correct. So we can't really manipulate until this statement is correct. We have to handle these limits of integration. So at this point, we have to figure out what is u when x is 1. So taking this lower limit of 1 and substituting it in here, 2 minus 1 is 1. So that gives us a 1 for the lower limit. And when x is 5, this is 2 times 5, which is 10, minus 1, u is 9. So now this is a correct statement. And so let's go ahead and work this piece out. We're going to pull out 2 times 2 is 1/4. So we have, this is 1/4, the integral from 1 to 9. U to the negative 1/2 times u to the 2/2 is u to the 1/2. U to the negative 1/2 times 1 is simply u to the negative 1/2. And this is du. So let's go ahead and integrate. And we get this equals 1/4. The antiderivative of this is u to the 3/2 over 3/2, so that's times 2/3, plus 1/2, negative 1/2 plus 2/2 is 1/2, so that's u to the 1/2 over 1/2, which is times 2, evaluated from 1 to 9. So as we've stated in the past, once we've gotten to this point, we can just go ahead and use our calculators to evaluate our antiderivative, and our final result becomes 16/3. All right, so let's move on to the next section.